Hey guys, welcome back to another next tutorial video. Today I am going to cover for some assembly commands. I will create a simple assembly. I will show you the basic interface of assembly, navigators and some constraints, how to assemble the parts and how to control their degree of freedoms. So let's start. I have some parts created already. To save some time, we can have a look of these three parts that we will try to assemble. We will use one part more than once so that we know if we have to reuse the part how to do that. And let's start. So I'll start with a new assembly file. I'll select assembly. Units are in millimeter. My name and locations are okay. I'll start with okay. So my new assembly file is created, and by default it activates the assemble command. Whenever there is a new assembly file created, it asks you to select the part which you want to start assembling. But I would like to add one coordinate system here first to have a better control of location or position of the parts. As always, we will add one coordinate system. Personally, I do not prefer the dynamic version. I always prefer the absolute CSYS because it stays on 0 and the chances of errors are reduced from the absolute CSYS. If you keep it to dynamic, then there are still chances that maybe while in clicking something, or you might accidentally click on any of the handle and the values will change, and later on to move it to 0 position might cost some broken constraints or anything. So it is always safer and best to keep it or start with the absolute coordinate system. So apart from this, uh, this coordinate system is always visible to 0 location, and we can switch it off by switching or clicking W on the keyboard just once to make it visible, and another hit will make it disappear. So this navigator you're already familiar with in our previous videos. This is a part navigator. All the history of the part will be here. As part of the assembly, we created one coordinate system, and for this assembly's part history will also be here. Anything we do as a part in this assembly will come in the history of this part or assembly. So we constructed something in the beginning, we created coordinate system, so it is here. But when we want to assemble parts, they will be done in the assembly navigator. So you can see assembly 2, the name of the assembly that we gave, and this is here. Now there are few things. Everyone can have their own preferences, but as best practices, I just set up some uh, columns that give me some information in the one look. While we move on, I'll explain everything, the importance of these columns. So let's start and call the first part here. So let's move to the assembly tab here, and the assembly commands are here, and there are two types of assemblies we can create: top to bottom and bottom up. And in one way, you can just start from a concept and a design in the mind, and you can start simultaneously designing all the parts together and switching the part environment, and you can build your machine in one go. But the other method is that you already created the parts just like I did, and we will just assemble the created parts in the assembly. So let's just call the first part. I will call this part first. So in our assembly, I will go to assemblies tab, and I will add part here by clicking on add component. Now I already have loaded parts, so loaded parts will come here, and I will select a tab. In this add component window, there are many options. We will go through some basics. Select part means which part do you want to add out of these loaded parts. I want to add tab, and these are the options. How do you want to place it? Component anchor would be absolute. How do you want to position in the assembly? Snap means there are three options: snap, absolute part, work part, displayed part, and WCS. Snap means if there is a bigger assembly and you are not near the coordinate system, then you can just pick snap and then select the object, and on the selected object near to that selected object, your new part will be added. And if you do not want to roughly locate or position the part, and you are sure of the position where you want to put it, just like in this case, absolute work part, my work part is this assembly, and absolute displayed part can be any other part which is not the main assembly, for example one of the child. So in my case I want to keep it in the absolute work part, so the work part coordinate system and the child part coordinate system will align to each other in the position. Furthermore, there are some options to uh, change the orientation of the part if you are not satisfied with the position. How do you want it? For example, when I created this part, I started from the center, so coordinate system picked the coordinate system of the part and aligned it to the assembly coordinate system. But let's take an example that I do not want it to be on the center, so I will use constraints, or maybe we can do the constraint part later. Let's just put it here. Okay, and by default it will suggest you to fix the first component of the assembly, and it is sometimes a good idea, but in for example in some of the companies, fix constraints is not preferred, just like in mine as well. So I will not use fix, and instead I will try to show you some other constraints. This component is added. Now if you just see here in the position column, there is a white circle. It indicates that my part is added here, but it is not constrained. When we will apply some constraint, you will see the difference here. I will let you know. So right click and you get the shortcuts of frequently used commands or the most common commands. I will use move command just to move this component out of the location, just roughly, so that I have a peek on my coordinate system that I created in the assembly. I need to have a look on these datums alongside the part so that I can create relations or constraints in between these two. Click OK. These movement of the component I did with the move command just to show you, but this could have been also done within the assembly constraint command that we are just going to begin. Let's start with the assembly constraints. These are the constraints which will allow you to freeze the degree of freedoms, along with, in some cases, maybe you want some degree of freedoms to act as you desire, as per your requirements. Let's start. So the very first constraint in the assembly constraint, these are the constraints that you can use, and the very first is touch align. This is a multi-purpose constraint. This constraint only covers up a lot of situations. For example, I'll show you. So touch align can be used to align two faces. It can also be used to align two axes, and it can also be aligned to give it some tangent relations between one circular face, cylindrical face, and the other flat face. So let's just begin. I want to just I want to align this corner to these two datums. How can I do that? By activating this command, I will pick the face that I want to attach of the part. This face I will pick, and I want this face to be touched or aligned to this datum. So now you see part has been moved to align this datum, XZ datum. If you want to confirm, you can just click on this datum cube, and it will show you exactly the location that it is aligned to, just to confirm. Okay, now similarly I want this face to match with this datum, this face to be matched with this datum. If you noticed, I just continued with my selection. I didn't do anything in the assembly constraint window. Once I am done with the one constraint, I keep on selecting more faces. It automatically switches to the next constraint command. So I used 4 faces to create the constraints, and it created 2 constraints. Let's just have a look. This was the first constraint. You can select here expand constraints. This first constraint was this face and this datum. If I just zoom here, sorry, the datum size will remain same. no matter how much I zoom in or zoom out. So I think it's pretty much clear that this datum is aligned with this face. Similarly, the next constraint, I just made the selection of this face and this datum, so these two are done. Now please note here in the position column, now the circle is half white and half black. It indicates it's partially constrained. White means it is not constrained at all, and if it turns to black, it means it is fully constrained. Means you have defined or freezed all the degree of freedoms. Now we have freezed two. We have freezed this face and this face. Now it cannot move in this direction, x direction. It cannot move in y direction. It cannot even rotate because we selected faces, face and datum. If we want the degree of rotation to be open, then what we can do is, instead of selecting the face, we could have just picked the edge. So what is left in the degree of freedom, we can always check as well, but we already know that in z direction this part is still free to move. We have to define what is the position in the z direction. If you want to check what is the degree of freedom still remain, you can just right click on the part and click show degree of freedom. It will indicate in the direction of arrows that this part can move upward and downward. And one more thing, I just in the beginning told you that move component command is used to move the components, but we can do that within the assembly constraints command as well. While selecting the command, you can check the degree of freedom by just moving the component. How can we do that? When the command is active, you can just pick any of the edges or face. For example, hover your cursor over the part, click and drag. It's just like picking up the part and moving. It will only move in the direction where there is any degree of freedom left. It cannot move in y direction, it cannot move in x direction, it will only move in z direction because we did not freeze the degree of freedom in z direction. So in order to do that, what we can do, what we want to do, it's not important the order of the selection, but we can in the beginning we selected the face first and then the datum. In this case we can pick the datum first and the face later, then also we will get the same results because coordinate system is absolute and it is not going anywhere. So if you notice, this is black circle, it means it is fully defined. So we just got our first part fixed, and this is the reason I just do not want to use the fix command. I want fully control of the part. Even in future, if you want to, we can just change these constraints from touch to distance, parallel, or any direction what we want. We can just switch the same faces and use the different commands. For example, that part we will come or cover in the maybe future videos. For example, if I convert it to distance, angle, parallel, perpendicular, align, lock, it is still the possibility. So let's add another part. Just for the experiment, we will use the same part twice or maybe 3 times to create the walls, and then we will add another parts. So I will add the same part, same process once again. Tab, I want to add the tab. Now I do not want it to locate on my absolute coordinate system. I want to use the snap option. Now the snap option, just move your cursor and your part will move along with. So depending on where your cursor is, your part can change the shape. Just notice when there is a vertical face selector, your part will change the shape of your suggested location. So I can just put it anywhere if I want to, and later on, even the assembly constraints that I used after finishing the add component command, you can do right here, so that you just skip or maybe save some time. So just click the constraint command here and use these constraints that are same available in the assembly constraint command. So if I use these constraints now and click OK, I will again have the new constraints added in the constraints section. So let's do that. So for this tab, I want to place it vertically in this left side and then on the right side as well. So in order to do that, I will use the same command. I will use this face to align with this face, and now I can also check the degree of freedoms. that it can move in this direction, up, down, and in this direction. So what other directions do you want to freeze? I want to freeze the x direction. We can do it two ways, this face to this face. I will preferably not use the datum now. I will use all the components to position on my first part, so that if I want to move the entire assembly, I will move the first part and all the assembly will move along. So I will assemble all the other parts that I add later, depending on the dependent on the first part. So we can also freeze the direction x by using these two faces. I'm not switching command, I'm using the same constraint. By just keeping on selecting multiple selections, it goes on with the next constraint. You can see the constraints are being added. So this position is also done. If I move, you can see both. Okay, let me just explain one more thing. Now there are two same plates, tabs, and you can see there is x2, means there are two. And if you want to see the individual position of these two tabs, just right click and click unpack. You will have individual constraints and individual entries of these two. I will add one more time just quickly in this side. Again, tab, location somewhere here, same constraints. Okay, all my three tabs are perfectly constraints. So these constraints are visible attachments that are placed here. For me, it is a personal preference. For me it is a little bit annoying, so I keep it hidden. I want to have a clean look of my assembly every time. So in order to hide that, just right click on the constraint section and click on this display constraints in graphic window. If it is already ticked, it means you can see. If I click again, it's not visible. So let's add the second part to our assembly. It would be the spacer. I will place the spacer here, and then I will add one pipe or tube to our assembly. So same process, add component. Okay, there will be a trick I will teach you now. Select the spacer, select the option snap. I just want to snap it somewhere. Now we already used the faces, two faces and faces to datum with the same command. Now we will use axis to axis. I will just demonstrate the same command with the different selections. When you click or when you take your cursor to a cylindrical face, you will see one axis will appear for your selection. You can click that axis. Now notice that there is no axis visible at this time when I have my cursor on a flat face, but as soon as I go on a cylindrical face, the axis appear. So in order to select the axis, you'll have to bring your cursor from the cylindrical face so that you bring the cursor or bring the axis visible. Now we aligned the axis, center axis, but we know that the face are still movable. So in order to freeze the face, this face should be aligned to this face. Now only degree of freedom is remained circular. So in this case we do not have any identification to freeze the rotation of this part, so we can leave it as it is. So now there was a quicker way to do these constraints. I just tried to show you these two constraints, axis to axis and then face to face, but there is a better way to do that, and let's do that as well. Now I want to undo the constraints, or maybe I want to check what constraints are used on this part. To do that, just click on the part, and there is one dependency tab here. Click on it and you will see, when you click on search, you will see in children the constraints that are used on this part. One is aligned and one is touch. When you click, you can also see which faces are used to create the constraints, and when you expand, you can see the other part, which this part is aligned to. Spacer is aligned to tab with these two faces using align constraint. Similarly, the touch constraint is used between spacer and the tab, and these two faces are used. So the quicker way I was just going to show you is using one single constraint to cover these two constraints. So in order to do that, I will just delete these constraints. I will again, just notice this is again white. It means there are no constraints applied to this part. I will move this part away just to have the clear visibility of the edges. Now there is another command, concentric. Concentric command will just make two circles coincident or coexist on the single plane with the single axis of the cylindrical faces, and it can also coexist on the same plane. So this, how this will help to cover up two commands at once. See, concentric command we will use for this edge and this the edge in the front. What it did is, this circle made concentric to this circle. This will also cover your 2 degrees of freedoms, because this circle and this circle will be bound to single plane, which is this face, and these two, because it is a concentric constraint, it will also bound these two circles to have a common axis. So this command will cover for two constraints. If you want to check the degree of freedom, same way, right click, show degree of freedom. You will only find 1 degree of freedom. There is a message in the bottom. There is 1 rotational degree of freedom left, that you can see it is clockwise or anti-clockwise. It can rotate, nothing else. Okay, just refresh to make these arrows disappear. I will add the final part here now, and this is the pipe. Again, go to add component and select your part, and I want to snap it for roughly position it somewhere. Now I will just show you some other constraints that we can use here. For example, I will use the same touch align. Most of the time, 80% of the time, you will use this touch align constraint, and most of your constraints will be covered within this single constraint command. So let's see how we can solve this situation. I want this pipe to start from here, go through this hole, and then we will see how the edge is aligned. Okay, so there would be a gap here because the spacer is only in this side. I didn't add it into the other side, so I think for the sake of learning it's okay. Let's move on. So first of all, I want to align maybe again concentric this edge to this edge, but I do not want it in this direction, so there is an arrow to reverse the direction. I will click on it, so it will reverse the direction. Now this pipe is locked to its center axis and locked to its front face, so it cannot move in y direction, it cannot move in x direction, but it can also not be moved in that direction, but it is free to rotate just like the spacer. So to check that, we can simply use the same process by clicking and dragging. Only the degree of freedom will be indicated by the movement. Now we can see it cannot move in this direction and any other direction except the rotation. Now rotation is depending on the situation or the requirement. I want to control this rotation. It can be done by making it perpendicular. We can use this axis and this face to always stay perpendicular, then it will be 90 degree. And we can use parallel. We can use parallel to this axis and this edge. It will keep it, or I'll just show you. Let's start with parallel. I'll use this axis and this face to be parallel. Now you notice here pipe is fully constrained, but let's not use parallel. If you want to try another constraints while staying in the command, you don't have to exit the command. You can just suppress the constraint by clicking on the constraint. I just added parallel constraint, it made it fully constrained, but for the experiment I will just untick, again make it available for the other constraint. I will use now the perpendicular, just position to ensure when the constraint is applied it is back to the position where I want it. This axis need to be perpendicular to this face. Again perpendicular added, this part is fully constrained. But if your requirements are neither parallel nor the perpendicular at some certain angle, then you can use this angle constraints. Now I want this axis to be 45 degrees to this face. Let's just give it 45, not in this way. Okay, maybe I should give it minus 45, or it will be 90 plus 45, 135. Yeah, this is what I wanted. Click OK. Again, it is fully constrained and the angle constraint added. These two will remain suppressed as you did in the command. So I hope the basics of the interface are clear. We added nearly 3 parts, and there are 1 part repeated 3 times. We can again pack it, and the packed result, if all these 3 copies of the same part are constrained fully, then only will come here as a black circle. But do not be fooled when there are more than 1 copy. You need to ensure all the copies are constrained by clicking on unpack, so that individual copy can be checked that all the constraints are defined or not. Okay, similarly there are other constraints as well. Fix is clearly I think there is no explanation needed. Fix is the fix. Whenever fix is used, whatever the position of the component is, it will remain there as fixed. Distance command can be used to specify distance. Let's try that. For this pipe we used concentric. Let's just remove that, or maybe just suppress, including angle we can keep it. So now we removed one constraint, suppressed one constraint, but there are 2 degrees of freedom released. We can just move this to check. See, it can now move in the x direction, z direction, even in y direction, because it was already freezed by concentric command. Now we will use the distance. So distance, okay, before distance let's at least align to the axis. Now to have a better picture of the distance, whether it is above this face or below this face, that's why I just aligned it to the axis first. Now use the distance. This face should be 10 millimeters above this face, so this face is 10 millimeter above this face. Click OK. Distance command or distance constraint is added. So I think pretty much basic commands are covered up. Align lock is another command to save some time, and but when you work for an organization, there are some set of policies with some restrictions, just like mine has, that avoid to use fix, and along with fix there is another name, align lock. Basically I'll show you what align lock does. Let's just delete all the constraints of pipe. Select all, delete. Now you can see it's white, means unconstrained, there is no constraint applied on this part. If I apply align lock is a combination of these 2 commands along with fix. It means that it can align the axis, and it will also freeze the degree of rotation which was left in these 2 constraint commands. I'll show you. So notice this is white, there is no constraint applied, and I will align. Let's align this axis with this axis. So you notice pipe will be dependent on with the align lock. It is mixture of both. It only has the degree of freedom in this direction. Rotation is also locked. In previous command we used angle to lock the rotation, but align lock will also lock the rotation, degree of rotation, and it depends how you select. If let me show you, in one command I can make it black. How? Just like the concentric. Let's just move this part first. Can you? Yeah. Now if I do not have the requirement to have faces on different height, then I can use copy of concentric command through align lock. I will use this edge, and it is completely locked. So what is the degree of freedom now left? Rotation. I told you this is the combination of these two. When it is applied as a concentric and when it is touch align. Well, it is I'm sorry, this will not allow the rotation, degree of rotation, but it is still showing degree of rotation because the spacer has the degree of rotation. Sorry for the confusion. Let me just again show you. Let's just delete these two. Move, move, please move. Now align lock will just use for this edge to this edge. See, this edge to this edge. Did you notice? All black. Now if you see the history or dependency, it has only one command, align lock, and this command will freeze all the degrees of freedom. There are no degree of freedoms and it is black. Similarly spacer is showing 2 because it is also attached to pipe and it is also attached to this plate here. So if you see, one align lock is for pipe and one align lock is for tab, so that's why there are two align lock. So I hope align lock is also clear. It is also banned in my organization, just like the fix. Fix can be used sometimes, but align lock is a big no-no because you just noticed that it saves time, but there is no control over the degree of freedoms that you want to have in your hands. Okay, then there are fit constraint. I never used this one, but as it says, two objects with equal radius such as circular or elliptical edges, it just constrains these two. This is a bond, and bond is also a time saving command. Let's just delete all these. Bond is the best example to define the bond command is having it welded together. So if let's just start with the fix. I just fix one plate. It says in the position that this one is fixed. Now if I use bond with one fixed object, so all the other parts that I will select in this constraint will be kind of as I tried to define, welded to the part that we select to. So if we want all the parts to be welded together and create constraint, then boom, all parts are in one shot fully constraints. Why? Because there is one part that is already fixed and all the other parts are bonded to this one part. So you see, all the part will have the same bond command in the history or dependency. Now if I remove or suppress the fixed constraint, every other part will also have the partially constrained status because it will move along with this part which was fixed earlier. Just to check it, see, or you can just have a look with respect to the coordinate system. It can move freely. So it was important to fix one part at least, and then all the other parts are attached to it. If I cancel the command by moving the parts, it gives you two options. Do you want to keep the changes that you just used or just discard? Sometimes when you accidentally move the parts and you're not sure if it is done as you wanted or not, just it is safe to discard the changes. It will come back to its normal or previous position. So if I undo the fix command, fix constraint will come back and everything is back to normal. So center is used when there are two objects aligned to one or two faces. There are 2-3 options in the center, and angle we have already seen. Let's just quickly see the center as well. Before that, let's just keep the fix and delete the bond. Okay, so if you noticed, this was our parent and these are our children. When you save the assembly, Saving the assembly, what it does is it saves the record of this assembly, that how many children are there in this assembly and how they are attached or assembled to each other with which constraints. And moreover, I will also cover the reference set, what is reference set, and in which condition they are placed in the assembly. So all these records are saved within the assembly part. So just to hide or unhide, these little arrows are good options. And for example, I want to hide pipe, I'll just click on the stick and it hides the pipe. Similarly, any part if you want to hide, just tick it, it will hide it. So I just showed you because I want to have a better clarity here, clutter free, to demonstrate the next constraint, which is center. Now when you switch to center, there is subtype. Subtypes are three types. Do you want to constrain one face or one object to two object, two object to with respect to one object, or two object with respect to two object? I'll show you what it means one by one. Let's just start with 2 to 1. In this case, center axis or use geometry, keep the default use geometry, or you can just use the center axis as well, but we will just use this axis as the selection, so it doesn't much matter here. I'm using 2 to 1 means two faces to with respect to one to keep in center. So just move it somewhere. So when we select 2 to 1, the order of selection matters here in this specific center constraint. So when you want to subtypes is selected to 2 to 1 means first selection would be the part from the part that you want to align to. So for example, these two parts I want to align with respect to the axis of this part. So these faces, two faces will be one face this, and make sure you use the same face of the other part. Same face in the sense the outer face. One face, two face. Now it comes to the one part. With respect to what? I want to make it center with respect to this axis. Did you notice? This part was a little bit further. Now it is moved to the center position. Now it can also be clubbed with the dimension command or the distance command. This face or this face. It is 437. Now just notice, if I reduce the dimension, both the parts will move simultaneously because it is also controlled with this center constraint. Whatever the distance I will give it here, it will always remain in the center or the half from this face to this axis. If you want to check it, this is now 420. Let's just measure. This face would always be half of that. It is 210, half of 420. Okay, so this was 2 to 1. Again, delete. Let's just move to another subtype. Now it is 1 to 2. It will be the other way around. In order to do that, fix from here will be deleted, but it will be applied to this, this and this. Now we have two parts that are fixed, but we want to put this part in the center of these two parts. Let's just change the position to see the results, dynamic results. Now it is not in the center clearly. Now switch to center constraint. Now change to 1 to 2. 1 would belong to the part that we want to constrain, and 2 will, the next will be from the part that are constrained to. So the selection order matters in this constraint. So the first selection would be the same, the order will be different, this, and the other two faces will be similarly this face and the outside of this face. Did you notice? The part moved from this position to the center. Now it will always remain in the center even if we try to move. If you have already noticed, when I want to move the part within assembly constraint, it cannot be done in all these commands. can be done probably in some of them which have the move capability. So that's why I always switch to this command when I want to move the part. See, because I selected the axis to be in the center, so it will always remain in the center irrespective of the other faces, which can further be controlled by other constraints. If I put this face parallel to this face, then it will just slide between these two parts parallel to this face, and similarly other constraints can be used to control the degree of freedom. So one subtype is remained. We can just check that out as well. Remove this center. Now switch to 2 to 2. Now I can use these two faces to center between these two faces. Let's just set. Now these two faces will be selected first from the part to be constrained. Now constrained 2. Now please note that this is a little bit on angle, less distance, more distance. When as soon as I select this face, the alignment itself will be corrected. See, now these two are also parallel and they are also in the center. If you want to check, we can just check with the measure command. This face is 110 from this face. This face is 110. So I hope you liked this video. All the constraints are covered. There are many more things in the assembly, and for example these things. Reference set. Let's just quickly have a look on the reference set. I'll just let you know the definition of the reference set. Reference set is the tool to control the visibility of the part. As you can see that every part has its own history. If we double click on the part, we can just see the history in the part navigator, and you can also see that this part, the part we double clicked on, is turned into yellow and other parts are grayed out. So it means this is the work part now, and the part navigator always will show the part history of the work part that is active in the assembly navigator. Now I was just explaining the reference set, and you can see there are many things in the part navigator, but when we are in the assembly, double click, you can only see the result or the 3D solid body, nothing else. I mean to say, when we were in the part history, there were coordinate system here, but we do not see that when we are here because it is set for model reference set. Now if you want to see the entire history including the sketches and everything, you can just change the reference set to entire part. Then you can just see the coordinate system, sketches and everything. Let me show you. If I just make sketch external, then I can see the sketch here. Now you will see the difference. I move back to assembly and just notice this part only has the entire part. Because of that, I can see the sketch here. There is the blue circle, that is sketch, but because these are two same parts and they are set to reference set model, they do not have the circle visible in these two parts, but only in this part. So I hope the reference set is also clear, and I think that's it for today's video. So I will thank you for your support, and if you like the video, please like and share the video with your friends and colleagues, and please subscribe to my channel for the support, and I will keep on creating for more informative videos in the future. Thank you very much. Have a good day.